the Java API. Here we have, which of the following valid expressions will create a string of value hello world? Now, when you're looking at a question like this, you have to make sure that your spaces will match up exactly. Don't go wrong because of something like that. You have to be very precise and very accurate. Okay, so here we have hello world is a string which gives you the objects when you press in a dot, the object methods. So it's a string class, obviously, that creates a string. And therefore, when you press the dot here, you're going to get the string methods. So trim is a string method. What trim does is it removes spaces from the start and spaces at the end. Does not do anything with the middle space. So that will give you hello world with a space in the middle. Okay. The next one is hello plus new string world. The problem there is that you're missing a space in the middle between hello and world. The next one, hello.concat. Is there a concat method in string? These are the kind of things you have to be able to remember now. And it's a space word. Yes, there is, and that will work. New string builder world dot insert. Yes, there's an insert method in that. At the very start, that's index 0. Hello space, and then gives the string version. Yes, that will do that as well. Dot append. Yes, there's an append, but there's no, the value 0 or the int is not in the first argument. It's down here. New string builder dot append. Hello space. And what this 0 and 6 is for are to determine the portion of the string that is to be appended to the target. Okay? So what you're talking about is this 0 and 6 of hello space that you want to append. So you're taking the whole lot of it. So what you end up with there is world hello space after that line there. So that's incorrect. And the next one is add. There is no add method in string builder. So yeah, that's grand. The next one, given that daylight saving time ends on November the 1st at 2 a.m. in the US Eastern time zone, what will the following code print? So you've got a local date time .of. Now that's how you create local date times. There's a few different factory methods. You never say new local date time because their constructors are private, and you'll often have to watch out for that. So that's the 31st of October at 10 a.m. 0 minutes. Now we want to zone it. Okay, so now we want to zone it for the US Eastern. That's how you do that. There's a zoned date time.of. You pass in your local date time and you zone it for US Eastern. Now the question really is about the duration.of days versus the period.of days. So what you're doing is you're adding a day to the date. And then we're looking to see, well, what time do you get? Okay, and there is a subtle difference between the duration and the period. They both do the same thing, adding one day, and then we output it. Okay? Now it says here, this question refers to zoned date time and duration, which are not explicitly mentioned in the objectives. However, a few candidates have reported getting a similar question, so they decided to include it. Well, we'll talk about it. The duration gives you exactly 24 hours, but it will incorporate daylight saving time. So we're in the autumn there in October, which means we will fall back 1 hour. You're going to go back, the clocks go back 1 hour. So 10 a.m. on the 31st of October will become 9 a.m. on the 1st of November. So that date there will be 9 a.m. and the date will be the 1st of November. Whereas the period adds a day, and that's it. There is no concept of daylight saving time. So 10 a.m. on the 31st of October becomes 10 a.m. on the 1st of November. And there is the answer to that one. 9 a.m. And what's this -5? You might be wondering. Well, that is the zone. -5 represents the time difference between Universal Coordinated Time, also known as UTC, also known as GMT, Greenwich Mean Time, and the US Eastern Seaboard. 5 hours. New York is 5 hours behind us. That kind of idea, that kind of thinking. Okay, so that's the answer to that one. Which of these expressions are true? Hello world dot equals hello world. Yes, that's correct. Equals compares the characters. Hello world dot equals ignore case hello world. Well, it doesn't matter uppercase or lowercase. Dot equals ignore case, doesn't care. Hello dot concat space world dot trim. Well, dot trim isn't going to do anything. There's no spaces at the beginning or at the end. Dot equals hello world. Yes, that's right as well. Okay. Now this next one is strange because which of them will return true? Well, that compared to is not going to return true. That's going to, oh, excuse me, it will. The compared to will return a number, and then that's comparing as to whether it's less than 0. And it's false. It will not return less than 0 because lower case numbers are larger. So what are we doing here? This is comparing each letter as we go along. And the first one is different. If they were the same, you go on to the next one. A bit like looking up a dictionary. And, okay, the lowercase letters are 32 larger than their uppercase counterparts. Unicode values, ASCII values. So in other words, lowercase h minus uppercase h is 32. 32 less than 0? No. Okay, so that is what is going to happen there. Does that make sense? Yeah. And then the last one, hello world dot to lowercase that equals, yeah, that's fine as well. Convert it to lowercase and then compare it to the lowercase h. There's the evaluate. So you can see here, although it's not required for the exam, it's good to know that for English alphabets, the Unicode value of any lowercase letter is always 32 more than the Unicode of the same letter in uppercase. So lowercase a minus uppercase a or lowercase h minus uppercase h is 32. So the way I remember that is lowercase is larger. That's how I remember that. What will the following code print? So there's your test. There's string builder test. There's main. Okay. String S is assigned hell. All right. So we have got string S is assigned hell there. String builder is referring to well. String test, call string test passing in S. Basically, this is it's the same value inside an S, but it's a separate variable. But it's referring to the same string object now. String objects are immutable. Okay, they are immutable. So therefore, when you call the replace, it's going to create a separate string object. And the H will be replaced with an S. But this object down here in main is untouched. It's untouched. This S is referring to the same object there, but when you go and try to replace, when you try to change the string object, Java says, well, you can't change a string object, it's immutable. So I'll make the changes for you in a separate string object. So that separate string object is called, well, has SELL in it. Replace will change all of the occurrences of H with S. There is only one, so it becomes SELL. but we've no reference to it. We haven't stored the reference. And as I was saying, the original S down here is untouched. It's still looking at HELL. The string builder is SB. We call that, so SB is passed in. There's a copy made of it. It's called S. So now that S and that SB are referring to the same string builder object. However, this time string builder objects are mutable. When you say s.append O, you are changing the object well to wello, and you're affecting what SB sees. There is no second object created when that happens, whereas there was when that happened. That's immutable. String builders are mutable. Therefore, when we come back down to here, we output the two of them. The S is still referring to the immutable string object hell, but the SB is referring to the mutable string builder object wello. So it's hell and wello there. Okay. Which of these expressions, I have this done in NetBeans actually. Which of these expressions will obtain the substring 456 from a string defined by string str is equal to 0, 1, 2, 3, 4, 5, 6, 7. So let's just put in the one that actually gives you the answer. We want to get 4, 5, and 6 from that guy there. So we want to start at 4 and we want to get 3. 3 from there. So that it'll go 7 minus 4 is 3. That's how you work it. Let's just make sure that we get 4, 5, 6 from that. 4, 5, 6, yeah. And then X is right beside it. So I did a substring with 0, 0. I got the empty string. Note it didn't actually print anything for that. Nothing at all before the X. I did the same thing for 4 and 4, and I got the empty string as well. I also did, the length of the string is 8, and I did a substring right on the 8. Okay, so it's 0 to 7. I tried to put in 8, and I got the empty string. So I output the print X just to show you that nothing is coming out. If I try this, substring on 9, I get a string index out of bounds exception. There it is, string index out of bounds exception. If I try to go negative, string index out of bounds exception. And if I try to go with something funny, where I want to start at 4 and I want to go to where basically this number is bigger than that number, that's a problem as well. String index out of bounds exception. So there's just some good examples for that type of a question. So the answer was substring 4, 7. Now let me just go back because there are some good pointers there. So I'll just evaluate it. Substring 4. What that means is go to the index 4. Now it's very useful that the string is starting at 0. 0 up to 7. That means start at index 4 and give us the rest of the string. Go to the end. 4, 5, 6, 7. Start at index 3 and give us 6 minus 3, which is 3. Start at 3 and give us 3. Here we go. Start at 4 and give us 2. 4 and 5. 6 minus 4 is 2. There's the index out of bounds. There's a few examples here, but critically it says here, the length of the substring is end index minus begin index, which is the way I've been explaining it to you. 6 minus 4 is 2 and so on. So hamburger.substring 48, start at 4 and give me 4, urge. Start at 1 and give me 4, 5 minus 1 is mile. So that's indices start at 0. Start at 2 and give me the rest of it. 0, 1 starts at the H. Start at 3 and give me the rest of it. Bison. And there's the empty string that I was saying to you, if you just go to the very end of it. Okay? And the length of that string is 9. Okay, emptiness. It's 0 to 8. Okay, the next one. Which import statement should be added to make this compile? Now, that's a pretty straightforward one because you're looking for an array list. An array list is in java.util. Okay? Java.lang is imported for you automatically. So java.util. Okay? Now, it says on that question, by the way, the only java.lang, if I evaluate that, only java.lang package and the package in which the current class exists are automatically imported. They're the only ones that are automatically imported. So what that means is that anything in java.lang you have access to, and the package that you are in, you'll have access to them. So if any other class in package X, I'll have access to. Any other class in java.lang, I'll have access to as well. That's what that's saying there. Number 7, that first line there. Okay. You've got a string.replace GG. Okay. Now, replace will replace all occurrences. Which of the following statements will evaluate to true? So basically, we're going to do some replacing over here, use the equivalence, and some replaces over here. Now, we want to know, is it going to be the same? Okay. Now, we're replacing lowercase g with a capital G there. And we're doing the same on the right-hand side here with the same string, literal. Okay? The thing you have to remember with replace is that you end up with new objects. When there is a replace, it ends up creating a new object. So that first one, okay, that created that. So we had our string, which is in the string constant pool, SCP. The first one on the left-hand side replaced the small g with the big G, but it created a new object. Okay? And the second one did the same thing. But you have two different objects now on the heap as a result of that. So therefore, it's going to compare the two of those for equality, and that's going to compare the references, and that's going to say, well, that's false. Okay? So let me go back and look at the second one. Here we're replacing lowercase g. Now note these are single quotes. These are characters. And that's important because if there is no replacement for replace using characters, then you get back the same object. It just gives you back the object that you're looking at. Okay? And you've got the same thing over here. Lowercase g with lowercase g. However, there's a new there. That's crucial. So that means create a new string. So if I go over to here, the left-hand side, there was no change with characters, so it just gave you that. Okay? Whereas here, we had a new, see, a new down here, and that meant that we ended up with a new object. So again, you're comparing two separate objects, therefore it's false. The third one, okay, we're comparing or replacing the lowercase g with the big G. So therefore, it's going to make a change because that is a lowercase g. That means it's going to result in a new object. And once you have a new object, well, you know, it's just not going to be the same. So this is the third one. We were working off that string there. And replace created this string here. This is the heap on the right-hand side, and that's the string constant pool down the left. So the replace created this one from that one. And then the right-hand side was the string literal. String literal is anything in double quotes like that. So therefore, that's going to be false when you compare them. Okay, so that was the string on the string constant pool. That's another string on the string constant pool. This one resulted in an object on the heap. And then you create the object references for the one on the string constant pool with the one that was created on the heap, and they're obviously going to be different. This is the one that works. So again, you're compared for the character G there, and you're putting, making no change, and you're comparing it to the string literal, which is in the string constant pool. So what does that look like in memory? Okay, so you've got the string, the replace returns the same object. That's what's at the bottom there. Replace returns the same object. So that's why the arrow comes back to itself. So you're comparing this one object with itself. So it basically comes back with true. Now, the tricky thing about this is when we evaluate it, it doesn't work the same way for strings. So it only works for characters. Okay? Method returns the same string object if both the parameters are the same. Okay? This is where you're using characters. When you've got strings, the char sequence is a string, it returns a new string, even if there is no change after replacement. Thus, string is equivalent to string.replace GG will return false. See, there's double quotes around those guys, single quotes around those guys. It's the exact same. There is the exact same as there. That's single quotes, double quotes. That one returns true, and that one returns false. So just have to watch out for that one if it occurs. Okay, the next one. Okay, here we have a space. Then we have a line which has space, hello, and another space, which is space, hello, space, 8, length of 8, if you like, because this is all about length. Okay. Then we do a line.concat world. That creates a new string, but we didn't store the reference. So it's just an object that's sitting out there on the heap, be garbage collected. Okay. We do a line.trim on this line here, and we store the reference in new line. So we do have a reference to this new object. Line.trim gets rid of the leading spaces and the trailing spaces. So you end up with hello. And then the output of line.length plus new line.length doesn't need to be cast to an int, it's just doing it anyway. And that's 13. So when you do the trim, new line is referring to a string object hello, whereas line has 8 characters in it, 3 spaces and hello. New line has 5. It's none of those, it'll print 13. You want to print the date that represents the upcoming Tuesday from now, even if the current date is a Tuesday. Which of the following lines of code accomplishes this? We have to select 2 options. There's 2 ways of adjusting your date, 2 patterns, if you like. You have your adjuster, and then you use the adjust into method, passing in your temporal object. What's temporal mean? Time related. It's your time object, your date object. It's time related. It's known as temporal. The other way is you have your temporal object and you use the with method and you pass in the adjuster into it. That's the preferred way. But they're asking for 2 here, and we'll go both ways. The first one is correct. So there's your local date dot now. There's another way of creating the local date. Dot of was the previous one. Dot now is this one. Okay. You can see, jumping ahead here, that new local date is wrong because you do not create local dates that way. Same with that one. You know it's wrong straight away. So there's the local date dot now with, how you pass in a temporal adjuster. And there's several methods on these temporal adjusters. But what was temporal means time-based again. We're adjusting a time or date. In this case, it's a date. And then we're saying day of week dot Tuesday. Yes. Okay, that's correct. The next one is the same idea here, except instead of next, that bit there, you're saying next or same. We don't want that because it says from now, even if the current date is Tuesday. That would give us, if today's date was Tuesday, to give us that. The next two are wrong because new local date. The last one then must be right, and that's using the temporal adjuster, where we used the local date with, and then you pass in the temporal adjuster. This is going the other way. This is the adjuster, and then you have your adjust into there. Temporal adjuster dot next dot adjust into, and then you pass in your temporal object. That works. And then it talks about that type of pattern. There's the two ways of doing it. The second one is recommended. The adjuster adjust into with your temporal, and then your temporal dot with, passing in the adjuster. Okay, the next one is available in NetBeans. So what will the following code print? S1 is an array list. We add in A, so you get A. Add B, adds after. C, adds A again. Yes, lists allow duplicates, okay? And order is maintained. LOD, as I say, Lord of the Dance, lists order duplicates. So the order has been maintained as I add them in. Now, the remove removes the first occurrence. To remember that. So we remove A, it removes that A. So you end up with BCA. Then we remove A again. Now, the second one is gone. BC is what's left. If that A was successful, which it was, then we go and remove B, and that leaves us with C. And that is on the wrong line because we just don't execute that. That's to output the. So C is the answer, and that is the second option. Let's go back and evaluate that.